So we're going to look now at 1-1. We're going to look at question 15. Now, I am not going to work this one completely out. I'm going to get you to the equation, or in this case, the expression, and you're going to simplify it down. So let's talk about question 15 on 1-1. Question 15, we are looking at simple interest. When we talk about simple interest, we have to make sure that our time is measured in terms of years and not in months. So we're going to read it, we're going to write up our formula, and then we're going to write up the equation and finish it from there. So Sophia borrowed $12,109. She borrowed that for 6 months and at 4.5% interest. So we're going to look at, in this case, simple interest. And our formula for simple interest is I equals PRT. And P is going to be the starting amount or the principal. R is the rate as a decimal, and T is the time in terms of years. So let's identify each piece and plug them into the formula. How much money does Sophia borrow? Yep. So she's going to borrow $12,109. Okay? And what about the percentage rates? Percentage rate is 4.5%. Be very, very careful when you convert that to a decimal. As a decimal, it's 0.045, right? Because there's a zero out in front. Always put the zero in front. That way you don't make a mistake. So always put the zero there in front of the decimal. Now, what we have to be careful of is time. Time is in number of years. Well, she only took this loan out for 6 months. So we're going to have to take that 6 and we're going to have to divide it by what? Divide it by 12, which is then a half, or you can write that as 0.5. Now, what about your interest? What would that be? You would just simply multiply those together. So you're just going to multiply those out, and that gives you part of the answer. So what does that give you? That gives you the interest, right? Now, once you got the interest, what do you have to find? You have to take that interest and you have to add it back. Yep, add that back to the principal, the $12,109. And so you're going to get two answers. One is the interest, and the other one is going to be the principal. Or not, the other one's going to be the total. Principal plus the interest. I'm not going to finish it. You can finish it from there. When I work out questions, most of the time, I'm not going to finish them out completely. Because they're homework questions, I want you to work them. But I will set them up and make sure you understand how to get to that equation. 1.2, we'll look at some of these, and we're going to begin with our first one. So this is a geometric figure type of problem. Now, we may or may not have to draw a diagram. You can if you want to. In some cases, you may need to. I don't think you probably need to in this case. But what we're looking at is we're looking at a triangular shaped lot of land. Okay, so a triangle has 3 sides. So we're going to get all 3. And it has a perimeter of 800 feet. One side is 100 feet longer than the shortest side, while the third side is 400 feet longer than the shortest side. And we want to find the lengths of all 3 sides. So we read it. Now, what do we know? We know this is a triangle, right? So that's the first step. How many sides are going to be in the triangle? 3. They're not the same. They're all different. So we're going to label these as the short side, middle side, and the longest side. We also know that we have a perimeter of 800 feet. And so the perimeter, is the sum of all the sides and that equals your 800. So what we do on these type of questions is we read it first, then we take our time, we look at what we've got, and we need to either draw a diagram if we need to, or in this case, we just label our pieces, label what we've got, try to build this equation. So we've got that 800, that's your perimeter, that's the sum of all the sides. Now, how do they relate to each other? It says one side is 100 feet longer than the shortest side, while the third side is 400 feet longer than the shortest side. So the short side, we don't know. That's unknown, so that's going to be the variable x. The middle side is going to be the short side plus 100, because that's our first one. And then the longest side is the short side plus 400, right? Because we've got a short side, we've got another one that's 100 feet longer, and we've got the last one that is 400 feet longer. Now, what does that look like in terms of the variable x? Well, when we rewrite this, we have our short side, x. We have our middle side, short side plus 100. So that is x plus 100. And then we've got our longest side, which is going to be x plus what? 400. All right, so there's your three pieces. Now, what do we know about the perimeter? Again, perimeter is the sum of all the sides. And that's going to be the short side plus the middle plus the longest. And let's rewrite this up, get our equation, and then I'll let you solve it. So the short side is x. We have that. The middle side is going to be x plus 100. And the longest side is x plus 400. And what is that going to equal now? 800. And I think you can finish it from there. Now, how would you finish it? You're going to solve it. You're going to get the variable x. Whatever x is x going to be your final answer? No. How many answers am I going to have? 3. Why am I going to have 3? Short side, middle side, longest side. 3 answers, and they're all going to be measured in terms of what unit? Feet. Not square feet. These are feet. Why? Because I can measure it with a ruler. Okay, so these are going to be in terms of feet. So you're going to have to finish it from there. Question 4 is a mixture problem. So I'll leave this one up so you can finish copying it. Let's look here at question 4. Question 4 is a classic mixture problem. Now, when we mix chemicals together, there are 3 things that are involved. The amount, gallons, liters, milliliters, whatever it is. So you have an amount. You have a percentage rate, the concentration of that solution. And then you have a pure. Okay, and pure is the amount times the percentage rate. What is the pure? Here's an example of what the pure is. Let's say I've got a container that has salt water in it. Now, if I boil off the water, what is left over is the salt, and that is your pure. So the pure is what happens when you take out the water. So if I have a salt water solution, if I boil the water off, the remaining part would be the pure. And pure is always the amount times the percentage rate. So amount times the rate. So now let's begin on this one. And again, I'm going to set it up, but I'm not going to completely solve it. In a chemistry class, 6 liters of a 4% silver iodine solution must be mixed with a 10% solution to get a 6%. When we make our diagram, we're going to find the amount and the percentage rate of each one of these containers, and we're going to multiply to get our pure. And this is question 4, by the way. So this is question 4 here. So each of these containers has an amount and it has a percentage rate. Box number 3 is what you want at the end, and box number 1 is going to be what you start with. So 3 is what you want to end up with. 1 is where you begin. So in a chemistry class, 6 liters of a 4% solution. So the amount on our first one is 6. Percentage rate is 4%, right? Okay, is everyone okay with that so far? Now, what are we going to do with that? We're going to mix that with a what? Yep, we're going to mix it with a 10% solution. Now, do we know how much is in there? Yep, unknown amount, so we use an X there. We want to mix them together, and we want to get out what? Percentage. We want to get out a 6%. So that's why the 6% goes here. Because that's what we want at the end. We add these across because 1 plus 2 is 3. So those add together, and that gives you, yep, 6 plus X there. All right, so that's how that one is set up. Now let's build our equation. And so to build the equation, we work with our pure. And pure is the amount times the percentage rate. And we multiply. So rewrite these with a percentage in terms of a decimal. So when we look at our first one right here, 6 is the amount. 4%, so that's 0.04. Second one, 10%, that's 0.1. How much is in there? Unknown amount, X. And what does it equal for the third one here? Okay, the third one is 0.06. And how much is in there? Yep, X plus 6 or 6 plus X. It doesn't matter. Remember, it's all commutative. You can switch the order, and you can finish it from there. So do you kind of see how I did the diagram? And it's going to make more sense when we do more of these. Students always struggle with these more than anything else. And it's a matter of taking your time, reading it, identifying all the different components, and putting them together. Question 5, very similar. So question 5 says, how much pure acid should be mixed with 5 gallons of a 50% solution, acid solution, to get an 80%? Now, what do we know about pure acid? What's the concentration of pure acid? That's going to be 100. So when we write that pure, we're going to label that with 100%. So let's begin by looking at the pure. So it says how much pure. So we don't know how much pure. So we're going to use an X to represent that. We've got our 3 containers. And so the first one, well, that's going to be your pure. And pure concentration is 100%. Unknown amount X. And we're going to take that pure and we're going to mix it with 5 gallons of a 50% solution. These add across again, so that's X plus 5. And what do we want at the end? We want to get what? Yep, we want to get 80%, so that's going here. Is everyone okay with that so far? Now we make our equation, and our equations are based on the pure. So the pure is the amount, again, times the rate. So 100% is 1. So that's going to be 100% times X. So that's just 1X or just an X. You could write the 1X if you wanted, but you really don't need to. What about the second one? What is it? 50%. So that's 0.5. We're going to multiply that by the 5 there. And what does it equal? On the right-hand side, that equals 0.8 for that 80%. And how much is in there? X plus 5. And I think you can finish it from there. Is everyone okay with how I set that one? If not, be sure and ask. We've got plenty of time to go over these. I always try to budget a lot of time for questions. 6, 7, and 8, well, those are investment questions. And I'm going to help you set those up as well. So let's now move on. We'll now look at question 6. So it is a investment question. So question 6 we're going to look at here. This is an investment one. Now, when we talk about investment, how is it different than the mixture? Well, not by much, because we still have an amount, we still have an interest rate, but instead of it coming out to be pure, we have interest earned. So we have an amount, we have a percentage rate, and we have the interest that you earn. Think about a bank account, okay, a savings account. If you have a savings account, what's in that account? How much money's in that account? What percentage rate it pays out, percentage-wise, and then also how much money that you made. That's your interest. So let's set this one up. Marty received an inheritance of $50,000. She invested part of it at 1.75 and the rest at 2%. So how would we set this one up? Well, instead of containers, we're going to use dollar signs. And then on the right-hand side, we've got a total amount. So that's going to be your total amount here. These are the amounts and percentage rate along with it. We've got 1 and we've got 2. So Marty received an inheritance of $50,000. Now, what does a $50,000 represent? What is that going to be? That is going to be what? That's not your interest. What is it? Total amount, right? Okay. So that means the $50,000 goes over here. That is your total amount, not the interest. Do not even look at the interest until the very end. It's the very last thing that we use. So we've got our total amount, which is $50,000. Now, we are investing it in 2 ways. So we are investing it in 2% and in a 1.75%. Doesn't matter which one goes where. They're the same. You can put them in either order. So 1.75% and 2%. Let's put them in that order. Now, do we know how much 1.75% we have? No. That's our unknown. So that's going to be x there. The second one, the 2%. What about it? Well, we can't just use the x again. And whenever you have two of these, one of them is x. The other one is the total minus x. Remember that? So total minus x goes there. And how much total do we have? So that's going to be 50,000 now minus x. So now we finish it out. We're going to work with our interest. Remember, pure is for the mixtures. Interest is for the investments. So the interest is going to equal the amount times the rate. And for our first one, 1.75%, so as a decimal, that is 0.0175, and we're going to multiply it by x. So there's that piece. The next one is 0.02 times 50,000 minus x. And then what goes on the right-hand side, that's how much money that we made. And on question 6, it says we made $900. So the 900 is your interest. And I think you could finish it from there. But you see how I read it through? I took my time. A lot of times, students just get intimidated by these. And what you need to do is just take your time, read it through once, and then go back and look at each individual part. And take your time with it and think to yourself, how does this fit into everything else? 2 more. We're going to look at 7 and then 8. And again, if you don't have it finished or you want to go back and finish some of these questions, you can turn it in on Thursday. If you've got it finished today, I'll collect it at the end. But if you want to wait and turn it in on Thursday, you can do that too. But let's look at question 7 next. Okay, question 7. Very, very similar. So 10,000, and we're investing it at 2%, 3.75%, and that's going to make 270 total. And in case you need the last one, I'll leave the last one up, in case you didn't get it copied. Sorry about that. In case you needed the last one. Yeah, might have moved too fast. But that's the last one. So let's work on 7. So we read it. And the first number that we encounter is that 10,000. And what does that 10,000 mean? That's my total amount, isn't it? So the total amount goes here. Is everyone okay with that? Okay, so that goes there. Next, let's talk about our percentage rates. What 2 percentage rates do we have? Yep, we've got a 2, and we've got a 3.75%. Almost exactly the same as the last one. Look at the last one here. First one was x, unknown amount. Second one was the total minus x, so it was 50,000 minus x. So what's ours going to be? The first one, what's it going to be for that 2%? It's going to be x. And what about the second one here? Very good work. It's going to be 10,000, right? Minus X, isn't it? Because that is your total minus X. So there's that piece. Now we look at our interest. And the interest is the amount times the rate again. Multiply these together. Make sure you're very, very careful with these decimals. So 2% is 0.02, and you bring your X down with it. The second one is 3.75%, so that's 0.0375. And how much is in there? 10,000 minus X. And what is it going to equal? Well, it's going to equal my interest. And how much did we make in interest on question 7 here? Yep, it looks like 270. And you can finish it from there. Is everyone okay with how I set that up? If you have questions, be sure and ask, because you'll see these type of questions on your exam. And by the way, our next exam will probably be next Thursday. So not this Thursday, but the following Thursday. So about a week and a half. Question 8. Let's look at question 8 here. We'll work this one out, and then we'll start 1.3. So question 8. Roberto invested some money, 2.75%, and 4,000 more than twice this amount at 3%. He made $1,257.50. How much did he invest at the 3%? So very, very similar to the last one. The setup is a little bit different for the amounts. So Roberto invested some money at 2.75%. So that's going over here. Now, do we know how much money needs to go in that 2.75%? Does it tell us at all? Nope. So that's going to be your unknown, so that is your X. Now, what do we know about the other one? Well, the other one, is a 3%, so that's our percentage rate. And it said it is 4,000 more than twice this amount. So that would be 4,000 plus 2x, right? Because twice the amount. Now, I always like to add them across. So what's your total amount? X and a 2x. That makes it a 3x plus 4,000 when I add them across. Is everyone okay with the setup on that? Now yours might look slightly different, but you'll get the same equation. What does our equation look like? When we build our equation, we're looking at our interest, and be very, very careful with those percentages. A lot of times students make a mistake with the percentages when they convert it to a decimal. Because we've got our interest, which is the amount, times the rate. And this is 1, and this is 2. So for the first one, multiply those together. Now it is 0. I always put the leading 0, so we don't make a mistake. 0.0275. X is attached to it. So that's there. The next one is 3%, so that is 0.03. And how much is in there? Yep, plus 2x. And then the right-hand side is going to be a number. And how much did we make? Yep. At 1257.50, so that goes there. And you can finish it from there. Is everyone okay with how I got that equation? Is it making sense? Okay. That then takes care of 1.2 questions. Now we're going to begin with 1.3. So I'm going to go ahead and pass out your new homework packet. And this will be due next Tuesday again. Okay, so 1.3 is what we're going to be looking at today. So what we're going to do today is we're going to do 1.3, which is a very, very short, easy section. And then we'll do a little bit out of 1.4. So let's begin with 1.3. 1.3 is not going to take us very long to go through. 1.3 is complex numbers. So that's the title of it, is complex numbers. Now, when we talk about complex numbers, we need a definition of I. I is called imaginary, and I is defined to be the square root of a negative 1. So that is what I is. Now, in previous courses, you have probably been told that this doesn't exist. This is not a real number. And it's not a real number. It's imaginary. In this course, we're going to be working with it. So in 1.3, we're going to be talking about complex numbers, and we're going to be learning how to break up square roots. So we're going to simplify some roots down. And we'll start off with a very, very easy one to work through. Now notice that negative is underneath the square root. What's the square root of 25? 5. Now because of the negative underneath, we're going to bring out an I. So this would come out to be 5i. So this negative here comes out as an I. So the only new concept is when you break up a square root, if there's a negative underneath, it comes out as an I. Now, what about the square root of 16, but we've got a negative in front? Now, this one's a little bit different. I want to make sure we see the difference. In this case, the negative is where? Out in front. What's the square root of 16? 4. And what about that negative? Where is it at? So it comes out in front and stays out in front. Let's try a couple more. Let's try a minus square root of minus 9 inside. We're going to learn how to break up some more complicated ones in a moment, but I want to show you the different scenarios that you may encounter first. I cannot cancel out the double negatives like that. Why not? Because one is underneath the root, one is out in front. When you cancel negatives, when the two negatives make a positive, that's multiplication. Now we have to do roots first. Then we do multiplication afterwards. So we have to handle the root separately, then the negative out front. So what's the square root of 9? Square root of 9 is 3. This negative here is going to come out as an I. And then the negative in front stays in front and keeps it negative. So that would come out as a minus 3i. Do not cancel those out. You do them independently. Do the square root first. There's that piece. And then the negative, if there's one out front, it just comes along with it. Now we're going to look at some of these where we have to actually break them down. So these were easy. These were not difficult at all. We just could use a calculator if we want to, or just mentally break them down. Some cases, though, we're going to have to factor. So let's try to break up this one. How about the square root of, how about a negative 200? So we're going to try to simplify this down. Well, how can we break up 200? Well, there's different ways of doing it. Now, what we want, though, is we want perfect squares. Yep, and when I see this, I've got the double zero at the end. So it's got 100 in it. And so I can break this up into 2 and 100. Now, you could also do 4 and 50. But I usually start with the smallest number first. So it ends in a double zero. It's an even number, so I started with 2. So it's 2 and 100. Now, what about 100? 100 is a perfect square of what? 10 and 10. We want our pairs. So the pairs are going to come out as 1. So I've got a pair of 10s. And so that's going to come out as a 10. We have a negative underneath. So this negative here will make it come out as an I. And what's left over that didn't match up with anything? So the square root of 2 is left over there. So your answer would then simply be 10i square root of 2. So they're not too difficult to break them down normally. Let's try a couple more, and then we'll classify the numbers. So let's try to break down the square root of 315. 315, again, is not a perfect square. Now, 315 ends in a 5. If it ends in a 5, I'm going to start with a 5. So 315, we've got to break that down by 5. That's going to be 5 and then 63. And 63, well, that's 3 and 21. And 21 is then 3 and what? 3 and 7. We've got it broken down as far as we can. Now, when we look at this, we want our pairs. So we have a pair of 3s. And so that pair of 3s comes out as a single 3. The negative here makes it an I for imaginary. And then what's left over? What's left over is 5 times 7, so we multiply those together. So that would come out as 3i square root of 35. Okay, we just multiply those together. So whatever is left over just gets multiplied together. And 3 times 5, that gives you now your 35. You might also encounter something that you can't break down at all. Square root of a negative 13. Well, 13 is not going to break down at all, will it? Right? All we can do is we can take an I out, and the 13 has to stay underneath the root. So in this case, the I comes out because of the negative, but 13 will not break down. Could be an 11. Same thing for 11. Square root of negative 11, it wouldn't break down. Now let's classify these numbers. And we're going to start by talking about how we classify them. Now, how mathematicians classify numbers is kind of like how a biologist would classify animals or a botanist would classify plants. We start with complex numbers. So all numbers are complex, just like all plants are plants. If you're a botanist, doesn't matter whether it's a shrub or grass, it's all plant. Same thing with numbers. All numbers are complex. So every number that we can work with is complex. So all numbers are always complex. And then we break the complex numbers down into the real numbers and the non-real complex numbers. Now, what are real numbers? Everything doesn't have an I, so that can be 5 minus 1.4, 8, 1/3, 0, negative pi. Those are all real numbers. So everything that you've worked with in previous courses has been a real number. All your other courses, you used real numbers. Now, what about non-real complex? Well, that means it's going to have an imaginary component. So non-real, that means imaginary. So what are some examples of these? Well, that might be things like 5i, 8 minus 7i, I square root of 3, 5 minus 3i square root of 7. Those are all non-real complex. And they are non-real complex because they have an imaginary part. Now, the non-real numbers can be broken down one further step, and they can be broken down into pure imaginary. And pure imaginary numbers, they do not have a real part. So pure imaginary numbers would be like 3i, 9i, 7i, I square root of 2, 4i square root of 5. Those are all pure imaginary. Okay, they do not have a real part. So when we look at these, let me break these up so we can see better. These are the real numbers. Non-real complexes is below it, and then pure imaginary. Now, when we classify these, they're going to be classified as more than one type. We're not going to break down the real numbers. We could break them into integers, rational, and irrational, but we're not going to. Okay, that's what we're getting ready to talk about. When I say non-real complex, it's a big subset. And inside of there is the pure imaginary. Like all of these under pure imaginary are also non-real complex. It's inside of it. And the diagram I'm going to draw next will kind of illustrate that. And at the top, we have our complex numbers. And then we break our complex numbers down into non-real complex. And we have real. So non-real complex and real. And then we break down the non-real complex numbers. They can be broken down further into pure imaginary sometimes. So the non-real, inside of the non-real is the pure imaginary. So non-real's here, it includes them, pure imaginary is inside of it. Now we're going to classify some numbers. And this is going to go with the first 3 questions in your homework. And I just made them multiple choice so they were easier for you to make sure you answered them correctly. So we're now going to classify some numbers. Now they can be more than one type. All of these are going to be at least complex. And either real or non-real complex, one or the other. So let's go ahead and classify these numbers. So we're going to classify the following. About -8. Start with that. -8. So here's our diagram. So -8. Now we first ask ourselves, is -8, is that real or non-real? Real. Now, if it's real, you follow it up. So it's real and it's also what? Complex. You have to follow it up. Everything is going to be complex. What about 5 minus 4i? Okay, non-real complex. And also, when you follow it up, complex. And sometimes they just write complex once, but it's actually non-real complex and complex also. What about the square root of -9 underneath the square root? Well, if I gave you the square root of -9, what's the square root of 9? 3. Bring out your I, so that's 3i. Okay, it's non-real. And what else is it? Now, be careful because it can be more. It's non-real. Is it pure imaginary? Yes. So it is actually 3 parts. It is pure imaginary. It is non-real complex. And it is also complex. So it's all 3 of them. Huh? Okay, pure imaginary means it has, I'll explain. Pure imaginary means it only has a non-real part. So this number, let's say I give you this, 4 plus 3i. Okay, that 5 out in front, when I talk about a number like that, that 5 out in front, okay, that is the real part. This 3i is the non-real. Right, now when because it has the I. The I is the non-real part. Now, when it only has a non-real part, then it's pure imaginary, because there's no real part. So like 3i, there's no number in front of it. There's no real part, right? So it's pure imaginary. And then it's also non-real complex and complex on top of that.
I understand that part. It is more of the pure, whether it's from pure to non-real.
Okay, yeah, everything that's pure imaginary is also non-real.
Right.
So when we look at this, I automatically know it's non-real. And then there's no real part, right? Like this 5 would be the real part. So when I look at the 3i, there's no number in front of it. So that means it only has an imaginary component. So that means it's pure imaginary, because there's no real part, non-real complex and complex. This would be not pure imaginary. Okay, this would be just non-real complex. Here, I'll list out some examples. It'll make more sense once we do some examples. These are all pure imaginary. So these are all going to be pure imaginary. 8i minus 9i, 4i, negative 3i. Those are all pure imaginary. These are not pure imaginary. Below it. 4 plus 7i. 8 minus 2i. 9 plus 7i. These are not pure imaginary. Why not? Because these have a real part in front followed by an imaginary part behind it. Does that make sense now? Okay. So pure imaginary has no real part. The only time that we ever really use these numbers is in the quadratic formula, which we'll talk about that next week when we look more into 1-4. But today, we do need to talk about complex numbers, talk about what they are. Now we've learned how to classify these. Now we're going to learn how to write them in standard form. And this is standard form of a complex number. And standard form is a plus bi. And the a is the real part, and the b is the imaginary part. So we can break these up into a real part, separated by addition or subtraction, and the imaginary part. So they have a real part and an imaginary part. Now, when we work with numbers that are non-real, we have to write them in standard form. So that's what we're going to be doing on the next 3 questions. And I'm just going to pick these from our textbook. So I'm on page 130. And we are going to look at question 42. And we want to write in standard form. So that's a plus bi. So that's what we're going to do. And we're looking at minus 9 minus square root of minus 18 over 3. So we want to write this in now what is called standard form. And this is what you're going to see when you work out the quadratic formula next week. Or not next week, on Thursday. So on Thursday, when we look at our quadratic formula, we're going to be working with standard form. Now the first thing we do is we break up the 18. So 18 will break down into 2 and 9, and then what? 3 and 3. So now the 3's are going to come out. And we can now rewrite this as minus 9 minus, the 3 comes out, I comes out with it, and what's left over? 2, and that's over 3. So let's take a moment to talk about where the I came from and where the negative in front of the 3 came from. First off, I cannot cancel the double negatives here. Why not? Because that's multiplication, and we have to do our roots first. So this negative just comes along out in front. Because it was negative underneath the root, the I came out with it. Now, when we write this in standard form, what we do is we separate each of them out into the real part and the imaginary part, and we reduce it. So we separate this out then into 2 separate fractions. And we reduce it down to get standard form. And minus 9 over 3, well, minus 9 divided by 3, that comes out to be a minus 3. those 3's can cancel, and that's going to be a minus I square root of 2. So we split these fractions out into 2 separate parts, and then we reduce them down individually. And this is a real part of a minus 3. The imaginary part is that minus square root of 2. So you have the real part out in front. The imaginary part is behind it. .45 is next. Well, let's not do 45 because it's got the same number. How about 44? 44's got a different root. So let's look here at 44. So we've got 20 plus the square root of a negative 8 over 2. First thing we do is roots. Remember, order of operations, roots come right after the parentheses. There's no parentheses, so we break up that root. And 8 will break up into 2 and 4, and then 2 and 2. And what are we looking for? Pairs. So this pair of 2's will come out. So we're now going to rewrite this as 20 plus 2. I comes out with it. 2's are gone. What's left over? Square root of 2. And that's over 2. Break it up into the individual fractions with these. And then we break it down and get our standard form. So break this down further. 20 divided by 20 divided by 2, that is a 10, so there's that piece. 2's cancel, so that leaves you now with I square root of 3. Oh, sorry, 2, not 3. I wrote it down wrong. My mistake. That should be a 2 there. Yep, didn't mean to do that. Sorry about that. But it should be 10 plus I square root of 2. My mistake. Okay. One more, and then we're going to look at 1.4. We're not going to finish 1.4 today. We're only going to do one part of it. So let's do question 46. So minus 5 plus the square root of a minus 50 over 10. Break up the 50. 2 and 25. 5 and 5. So the 5's come out. And let's rewrite it. So now we have a minus 5 plus 5. I comes out with it. Square root of 2 is left over. And that is all over now 10. Is everyone with me so far there? Now, we need to break this up. And if they're fractions, we keep them as fractions. We go ahead and break this down into the real part, which is minus 5 over 10. And then we have a plus. We've got 5I square root of 2 over 10. And we can reduce minus 5 over 10. Well, that's going to reduce down to a minus 1/2. And 5 over 10 reduces. And that's going to leave you now with a square root of 2 over 5. And then we can put the I at the end. You can put the I either right in front of that square root, or you can put it at the end. Normally, if we have a fraction, we put the I at the end. As long as the I is there, I'm okay with it if you want to put it in front or if you want to put it behind the fraction. But as long as I can find an I, that's all I'm looking for. Oh, yep, I wrote it wrong, didn't I? Sorry, not thinking today. That should be a 2 there. My mistake. I'll try not to make any more. But that should be a 2 down below because 5 over 10, you'd actually have a 1 there, but we don't write it. And 5 divided by 10, that leaves you with a 2 there. So now we're going to look at a little bit out of 1, 4. 1, 4 has 3 parts to it. We're going to cover the smallest part today. 1, 4 is a really large section. 1, 4 has solving equations using the zero factor, which we'll talk about next class period. We're going to learn how to use the square root property today. And next Thursday, Thursday coming up, we're going to do the quadratic formula. So we're going to go ahead and do the square root property today. On Thursday, we'll do zero factor and the quadratic formula. The square root property builds on what we just covered today. And we're going to learn how to solve these using the square root property. So this should match up with your homework on 1, 4, 6 through 10. And I made them multiple choice just so you could see if you got your answer correct or not. That way, if not, you can work it out again. Because I know sometimes you'll work them out and you'll think you're on the right track, but you're not. So at least this way, you'd be able to say, hey, my answers don't look anything like these. So I need to go back and look at them again. But we're going to learn about the square root property and how to solve using the square root property. Now in mathematics, we look at opposites when we solve. How do we get rid of a positive? We use a negative, right? Addition, subtraction are opposites. Multiplication and division are opposites. How we get rid of a square is we use a square root. So a square and a square root are opposites. They undo each other. Now what we have to remember is whenever we take a square root, we always add in a plus or minus, because we're going to get 2 solutions on these. So whenever we take a square root, we add in plus or minus. Now we're going to start with some really easy ones. And so let's say I give you x squared equals minus 9. Okay, x squared equals minus 9. I'm going to end up with 2 solutions. And I have a square. How do I undo a square? What's the opposite of square? Square root. So I'm going to take the square root of both sides. And this builds on what we just covered. And whenever we take the square root, we have to add in a plus or minus. Now we just talked about the square root of a negative 9. Well, the square root of 9 is 3. It's negative underneath, so it's going to be 3i. And do not forget the plus or minus. Yep, and that's your answer right there. It's plus or minus 3i. What that actually means is this. It's 3i, and it's also a minus 3i. It's just a shorthand way of writing both of them at the same time. So plus or minus means there's actually 2 solutions. A positive 3i and a negative 3i. Let's try another one. X squared equals 75. Same concept. Now, how do we undo a square? Square root. Whenever we take a square root, we add in a plus or minus. And we need to break down the 75. So how does 75 break down? 3 and 25. And 25 is a perfect square of 5 and 5. And we want perfect squares. So that's going to come out then as a plus or minus. The 5 comes out. The square root of 3 is left over. Is there an I in this at all? No, why not? Because 75 was positive, right? This is a real number. Why is it real? Because there's no I on it at all. So it's a real number. Now let's move on. And we're going to do 2 of these where we have parentheses. So I want to give you something like this to solve. And before I forget, I'm going to also pass out the sign-in sheets. But we're going to do a couple more questions. Just want to make sure I pass out the sign-in sheets. Make sure you sign the sign-in sheet. If your name is not on there, it might be that you just add it recently. So if your name is not on the sign-in sheet, just add it at the bottom. And that was printed off yesterday. So how would I handle this question? First thing I need to do is get rid of a square. Now, we do not have to FOIL this out. A lot of times I see students trying to make this question more difficult than it needs to be. We can get rid of the parentheses just by taking a square root. So let's do that. So we're going to take the square root of both sides. And whenever we take a square root, what does that add in? Plus or minus. That square root and that square, they cancel. So that leaves you with a 4x minus 9. And then we've got plus or minus. And what's the square root of 25? 5. Now in this case, I want you to get the 2 solutions. So we're going to have to solve the 2 equations to get the 2 solutions. And so what are my 2 equations going to look like? Well, they are going to be 4x minus 9 equals 5 for the first one. And 4x minus 9 equals a negative 5. So I'm going to get 2 solutions out of here. Is everyone okay with how I got the 2? Now we solve it. So just use your algebra like you've done before. So add the 9 over. That gives you 4x equals now, looks like 14. Divide by your 4 and reduce. So that comes out to be 7 over 2 when I reduce it down. There's one solution. How do I get the other solution? Yep, same procedure. You have to add that 9 over again. And now I've got 4x equals now, adding down, 4. Divide by 4, and that leaves you now with x equaling 1. 1. I want to do one more question just to make sure we know how to answer these and how to get our answer to look like the multiple choice questions as well. I made a multiple choice just so you'd be able to find your answer and so you'd know how they're written and how to write them correctly. So let's do one more. How about we look at this one? Let's try and solve 3x minus 1 quantity squared equals 5. So I want us to try and work on this one. So the first thing we're going to do is we're going to get rid of our square by using a square root. Add in your plus or minus. that gives you then 3x minus 1 equals plus or minus the square root of 5. Now, we need to solve it for the variable x. So we can add 1 to each side, and that stays out in front. And then what can we do next? We can divide by our 3. And that's going to give us now x equals, when we moved it over, 1 plus or minus the square root of 5 over 3. And you can leave it like this, or you can write it as this. It's okay to write it also like this. Okay, so either way is fine. Either this way, or you can write it like that. Normally the textbook leaves it like this when there's no imaginary part. Or you can split it up. Either way, they are the same. But does everyone see what I did? So let's review it again. How do I get rid of the parentheses? When it's squared, square root. When I take a square root, what do I always have to add in? Very important. Plus or minus. You break up the square root if you can, but 5 will not break down at all. So then I just moved my 1 over. I divide it by my 3, and you can either leave it like this, or you can separate it out into 2 fractions. Now, what's going to be our homework? Well, our homework now, or what we've covered, is we have covered 1.3. You should be able to do them all. 1.4, you should be able to do, I believe, 6 through 10. Because those are the square root property problems. And I will see everyone then on Thursday. Now, if you have your homework done and you want me